Okay, so what you're going to do, if you haven't already, is you're going to fold your paper into fourths. And then what would be considered the center of the paper right here, you're going to fold down like a little potato chip size, like a tortilla chip corner. Okay, so just a reminder, this is the middle of your paper, and when you fold that corner down. And then when you open it up, you're going to have 4 corners and a little diamond shape in the middle here. And then I'm going to darken up some of the lines just because it will help me. You can too if you'd like. Okay, so it ends up looking like this. Okay, so what we're going to do is we're going to just look at what strategy or what method for solving systems of linear equations would be appropriate given the equations for each problem, okay? So we're going to be, we can put our title here, so solving systems of equations, and we have graphing here, and we're going to do substitution, and then we'll do elimination down here. So we'll have one blank corner because there's only 3 methods. Okay, I want to start in the graphing square, and I want to show you what equations would be appropriate for graphing. And actually, what did I do with my notes from last class? Here we go. All right. So graphing. An example of an appropriate situation for graphing is when they are already solved for y. So if you get a system that looks like this, y is equal to -5 halves x plus 1, and then y is equal to 1/2 x plus 7. Now there's a couple reasons why you're going to want to graph that. The first one is it's easy. Everything is solved for y. The second reason is you have some funky fractions. Well, they're not funky, but fractions always make things a little harder and more challenging to manipulate, okay? But when we're looking at those fractions, we know that those fractions represent slope, which we can quickly and easily graph, okay? So when I see a system that looks like that, I'm thinking right away that graphing is going to be my best technique for solving. So let's do that. Let's get our coordinate plane on here and graph these two. I'm going to try to make my coordinate plane kind of big because we have a y-intercept of 7. So we want to make sure we have some space up on the y-axis. Okay, so the y-intercept here is 1, and my slope is -5/2, so I'm going to go down 5 over 2. I'm going to plot a point the other direction too, so that it makes it easier to graph. And then my second equation, my y-intercept is 7. And my slope is 1/2. So I'm going to go up 1 over 2, up 1 over 2. And I'm going to connect it to make a line. Right away I can see where those two equations cross. And it's right here. And so the solution to that set of linear equations is -2, 6. Now, if you're doing an assignment or homework, I would expect you to check your answer, but for right now, we will leave it off. Yeah, Jordan?
With the first problem, it's up 1, but isn't that -5, so won't it be down 5 over 2?
Yeah. So I went down 5 over 2. Okay, so that is an example of a perfect situation for graphing. Now let's take a look at substitution. You know it's a good candidate for substitution when one of the variables is already solved for, or it's easy to solve for one of the variables. For example, this system right here. This is solved for y right here. So it'd be super easy just to plug this in and solve for x. It even could be an equation that could be easy to solve for a variable. So if you have like an equation that's not in this form, but you could quickly and easily just solve for a variable, then you can use this method. Okay, so let's do it. So I'm going to take this whole thing that y is equal to and plug it in for y. So this is going to be 2x minus the whole thing, -3x plus 1 equals -6. So I just replaced y with what y is equal to above. Now I can go through and simplify. Make sure you're distributing the negatives. So this is plus 3x minus 1 is equal to -6. Combine like terms. And then solve for x. So I'll add 1 to both sides. So I get 5x is equal to -5. Divide both sides by 5. And I get that x is equal to -1. That's our first piece of important information. Now, it doesn't matter which equation you plug it into, the first one or the second one, and then you'll solve for y. I'm going to just use the first one. Since x is -1, I will plug in -1 here for x. And then I'll solve regularly. So -3 times -1 is +3. 3 plus 1 is 4. So our solution this time is x is equal to -1, y is equal to 4. And like I said, if we were doing this on a homework assignment or a test, I would hope that you would check your answer to make sure that it works, okay? So like I said, substitution is great when you have one variable already solved for or one variable easy to solve for. Now, as you guys learned when we were doing IXL, you do not want to try to use substitution when you have two equations in this form. Okay, it just trying to solve for one of the variables when this is considered standard form, when these are in standard form, is very challenging sometimes. In this case, it wouldn't be too bad because you could probably just solve for x, but usually if it's in standard form, you just want to go straight to elimination. It's the easiest method for systems like this. So that's what I'm going to do. And when I'm looking at this system, I have options here. I could multiply the top equation by 2, and then these would cancel each other out. Or I could multiply the bottom equation by 3, and then the y's would cancel out. So let's go ahead. I'm going to just multiply the top equation by 2. But you can multiply by whatever you want as long as it works. I'm going to run out of space. I'm going to come a little lower. So this will be 2x minus 6y. Is equal to negative 18. And then we have negative 2x plus y is equal to negative 2. We're going to add these two equations. So, and here, let me pull it up so you can see. 2x minus 2x, that has a value of 0. And then negative 6y plus y is negative 5y. And this is negative 20. Divide both sides by negative 5, and we get y is equal to 4. Then we're going to take 4, plug it in for y in one of the equations. It doesn't matter which one. I'll just choose the first one. And x is equal to 3. So your solution to this system of equations, x is 3, y is 4. Okay. Do you guys feel like you can select the most appropriate method when you're doing your work? All right. Go ahead and get to it then. If last class, I don't think I had anybody that had gotten to 80 by the end of the class, so I just made the SMART score for that 80. Okay, so today's code, CC.12, SMART score of 80. Okay, if you finish super early though, push yourself. What's that? Yeah, because they changed it because it seemed like people needed some extra that weren't going to be able to finish, basically. And those of you that finished early can go back and work on other skills that are starred, the extra skills I posted in Otis, or work on your recommended skills. You can also, if you haven't already, you can take the diagnostic too, and then it will give you better recommended skills. It will tell you exactly what you need.